Hey, so let's look at a second part of dividing radicals. So in the previous video, we looked at dividing radicals when you just have a single radical in the denominator. By a single radical, I mean you have a monomial. You have something like 3 over square root of 2. When you have a monomial in the denominator, you can just multiply both top and bottom by that monomial. And you can say, well, 3 times square root of 2 is just 3 square root of 2. And square root of 2 times square root of 2 would just be 2. It'd be square root of 2 squared, so 2. When I have a binomial in the denominator, it's a little bit different. So I still want to get rid of my radical. I cannot divide if I have a radical in the denominator. It's a little bit easier. I can kind of skip the first two steps. I don't really have to worry about simplifying a fraction. I'm not going to even try to figure out how to simplify this fraction right here. The 3 plus square root of 2 over square root of 3 minus square root of 5. And I don't really have to worry about simplifying my radicals. Square root of 2 is not simplifiable, square root of 3, nor square root of 5. So I can skip the first two steps. Only thing I have to worry about is still rationalizing. In this case, we're going to see what happens if we try to rationalize just by multiplying by, say, the first radical in the denominator. So say square root of 3 over square root of 3. If I do that, I'm going to have to distribute. I'm going to have to take the square root of 3 and multiply it times square root of 3, which will be fine. That would be square root of 3 squared. That would just be 3. I'm good with that. Then I would have to take it and distribute it times my square root of 5. That's where my trouble comes in. That would be square root of 15, which means I still have a square in the denominator. Okay, so square root of 3 didn't work. Same thing with square root of 5. I can multiply both top and bottom by that. I'd still have the same problem. This is where something called a conjugate comes in. And we've actually worked with conjugates before. Conjugates, I'm going to go all the way down to the bottom of the page. So conjugates come from when we've worked with difference of two perfect squares. So we've seen it before, something like x squared minus 4. We've known how to factor this. X squared minus 4 is x minus 2, x plus 2. And we know that because I can multiply my x times my x and get my x squared. My middle terms cancel each other out. Plus 2x minus 2x cancel each other out, and then my last terms, minus 2 plus 2 minus 4. So if I multiply by the conjugate, which all conjugate really means is change the middle sign, so from a minus to a plus, then my middle terms will cancel out. I'll just get that first term squared minus that second term squared. So I'm going to use that idea here. Instead of having a minus square root of 3 minus square root of 5, I'm going to multiply by times square root of 3 plus square root of 5. I am going to have to FOIL. It's going to kind of be annoying. So on the top, I'm going to FOIL. I'm going to get 3 times square root of 3 is 3 square root of 3. 3 times square root of 5 is plus 3 square root of 5. Let's see, enter square root of 2 times square root of 3 is plus square root of 6. Square root of 2 times square root of 5 is plus square root of 10. Going to FOIL the denominator. Square root of 3 times square root of 3, that'd be square root of 3 squared. Okay, so square root of 3 times positive square root of 5, positive square root of 15. Okay, start with my minus square root of 5, my inner. So minus square root of 5 times square root of 3 minus square root of 15. Minus square root of 5 times positive square root of 5 minus square root of 5 squared. Look at your numerator. Can you simplify any of your radicals? I can't, so I'm just going to write them. 3 square root of 3 plus 3 square root of 5 plus square root of 6 plus square root of 10 over my denominator. Check and see what you can simplify. Square root of 3 squared is just 3. Positive square root of 15 minus square root of 15 cancels. Minus square root of 5 squared is minus 5. So I'm going to have, again, my numerator I can't do much with. So I'm just going to recopy it. It's annoying. plus square root of 6 plus square root of 10. So 3 square root of 3 plus 3 square root of 5 plus square root of 6 plus square root of 10 all over negative 2. That's it. Okay. So I'm going to check next one. I have square root of 6 minus square root of 5 over square root of 2 plus square root of... No, just plus 1 actually, not even the square root of 1. Again, I can't simplify my fraction. I can't simplify my radicals. So I'm going to go ahead and multiply by the conjugate. Whenever I have a binomial in the denominator, I'm going to multiply by the conjugate. What that means is go ahead, just change your middle sign of your denominator. So if I do that in the top, I'm going to have to FOIL. So square root of 6 times square root of 2 is square root of 12. Square root of 6 times minus 1 is minus 1 square root of 6. Minus square root of 5 times square root of 2 is minus square root of 10. Minus 5 times minus 1 is plus 1 square root of 5. The denominator, square root of 2 times square root of 2 is square root of 2 squared. Outer, minus 1 square root of 2. Inner, plus 1 square root of 2. Last, minus 1. Okay, so I'm going to try to simplify this more. Square root of 12, I can actually simplify. Square root of 12 would break down into square root of 4 times square root of 3. So I'm going to get 2 square root of 3 minus square root of 6. I can't do much. There's no reason to write the 1. Minus square root of 10. I can't do much. Plus square root of 5. The denominator, square root of 2 squared is just 2. Minus 1 square root of 2 plus 1 square root of 2 cancel. Minus 1. So I'm just going to get 2 square root of 3 minus square root of 6 minus square root of 10 plus square root of 5 all over 1. Writing stuff over 1 or dividing by 1 doesn't change anything. So I'm just going to keep it like that. Okay, next one. Say I have 7 over square root of 3 minus 2. Again, it's a binomial in the denominator. When I see a binomial, I'm just going to multiply top and bottom by the conjugate, meaning change the middle sign. Okay, in the numerator, I'm going to get 7 square root of 3 plus 14. The denominator, it wasn't a 2 binomial, so I didn't have to FOIL this time. So I did just distribute the 7. The denominator I will have to FOIL. So square root of 3 squared minus, sorry, it's a plus, isn't it? So plus 2 square root of 3. Let's see, minus 2 square root of 3 minus 4. So I'm going to get 7 square root of 3 plus 14 over square root of 3 squared is 3. 2 square root of 3 minus 2 square root of 3 cancel. Minus 4. So 7 square root of 3 plus 14 over negative 1. Okay, divide something by negative 1. It's the same thing as dividing every term by that negative 1. So negative 7 square root of 3 minus 14. And done. Okay, let's try the last one. Square root of 5 plus 4 over square root of 2 minus square root of 3. Again, can't simplify any more radicals, can't simplify the fraction. So let's go ahead and just multiply then. Don't even have to draw the arrow. We'll multiply by the conjugate. So square root of 2 plus square root of 3 and square root of 2 plus square root of 3. Just change that middle sign. Okay, so if I distribute, oh, this is 2 binomials, so I will FOIL. 5 times square root of 2 is square root of 10 plus square root of 15 plus 4 square roots of 2 plus 4 square roots of 3. The denominator, square root of 2 times square root of 2 is square root of 2 squared plus square root of 6 minus square root of 6 minus square root of 3 squared. check the numerator. I can't simplify anything. I have no like terms, so I'm just going to keep it as square root of 10 plus square root of 15 plus 4 square root of 2 plus 4 square root of 3 over square root of 2 squared is 2. Positive square root of 6 minus square root of 6 cancels out. Minus square root of 3 squared be minus 3. 2 minus 3 would simplify to a negative 1. So again, it's all over a negative. So it's just going to be like dividing every single term in my numerator by a negative. So minus square root of 10, minus square root of 15, minus 4 square root of 2, minus 4 square root of 3. And that's it.